Good evening. So we will now, today we are going to look into the network analysis part of GIS. So basically, whenever we talk about the network data sets, so most of the time we are concerned with the services where it should be, in that case, we should be able to have map around particular locations. So we should be able to see those. Then it should also be provided to show the shortest path from any one destination. Most of the time we are interested in finding the shortest distance from the user's current locations to some destinations. And this also is now being used or is being now integrated with the intelligence navigation systems where automated car, vehicle, and routing systems are integrating with the network system. So generally, whenever we want to do network analysis, the most widely used application is the navigation systems. So in this case, generally we look for a kind of three major services, which is location based. One is the location, just to find out where we are. So it means like you need to have some kind of information systems where giving the current latitude or longitude values, you should be able to convert it back into the name, places of a particular area. So that is called geocoding. So like you'll be having a lat long values available from your devices, mostly mobile devices is being used nowadays. Small devices has a GPS system which just gives the latitude and longitude values. But once you have a latitude or longitude values, then that needs to be converted to a real-time location. So that location gets converted through geocoded services. It means like you provide a locations and corresponding names can be added. So that's basically names can be provided. So it's a reverse geocoding. And sometime you will be having a latitude and longitude values, and you would like to tag it to a particular name, place, and so on. So that's basically a geocoding. Then there's an also another services which comes under the location-based services is directory search. So in this case, we are mostly interested in to find out nearest services. For example, where is the nearest clinic or where is the restaurant? Where can we find out the nearest taxi? And in some time, we also provide a range bound services that we would like to find out all the uh, like in this case, at a bank within a mile. So this kind of services, if you want to find out, that is called a directory-based search. So it just gives you a searching based on your network data sets, finds out the distance of all these services, and corresponding places is being highlighted or displayed. The difference between directory search and the buffer analysis, the point-based buffer analysis is that in the buffer analysis, it just takes the Euclidean distance or the aerial distances between any point. So wherever we get an cutoff of that distances, so that you get an output around surrounded by around a point like a circle. But in case of directory search, you do searching on the network data set. So you take the actual road length, distances, or maybe some other cost associated with that consideration, and then you compute the target locations. So this is slightly different from the buffer analysis. Then we have a route, basically the different routes we need to find it out, like how to go from one place to the another place in the shortest distance, or maybe in the shortest time with the shortest petrol consumptions and so on. So like minimum petrol consumptions and so on. So those kind of cost effective measures can be added to your analysis, and all these are quite widely used in different navigation systems. So all these navigation systems generally works on a network, that is the road network, which has a few characteristics. Generally, you can say that it is just a representation of on conceptual level connection between edges and points. And it can also be, the analysis can be carried out in vector and a raster data set both. So it means like you can represent the networks in a raster and vector data. Give the example, apart from road network is the utility network, power line networks. You're also having different networks related to water distributions and so on. So those are also another examples of networks where network analysis can be carried out. But in most of the cases, what happens is we carry out network analysis mostly on the basis of graph theory, and we considered all this point line vector as a unique component of that, and then we carry out different type of transportation, like finding out the shortest distance, what is the connectivity in other matrix. So second level or third level of informations can also be extracted apart from just finding the route and distances. So in general, networks can be a directed one or undirected. So it means like you'll have a network with flow of material in just one direction. The best example is the river. So it's like upstream to the downstream, there is a flow of water. So that's the kind of mass flow. So that is called undirected. And in case of general node network, we may have pathways flow of materials, like in the case of streets, where the vehicles can go from one edge of the road to the another edge of the road in the directions. So if you have just one direction, then you call it as a directed, basically the node directed network. But if you're having the connection in just both the direction, then it is called undirected network. So even if you have a single node kind of edge of a particular segment of a road being directed, then the whole network gets converted into directed network. So you have to fix that particular aspect in during the analysis as well. Then there's another type of a few modifications of general two-dimension networks. So it can be planar or non-planar. So it means like we have network edges not only staying in just on a single surfaces, but it can go across in multiple surfaces. For example, is that over bridge and so on. So if you're having a bridge and other kind of network component, network systems, then those will fall into basically a non-planar networks, and that can be multi-levels. You're gonna have more than one planes in which the different kind of edges can be put in. And the other example is tunnels and the under bridges and so on. Those are the different examples. But in general, the planar networks are the connection of different river stream, or the drainage network are an example of planar. Most of the current transportation systems, which is available in different cities, are actually an example of network. Then there's also another categorization of the network, which is that if you just consider a single component in your network, then that is called a single model. For example, if you're having just a road network in your analysis, then those are single model. And then you have a multi-model in which you can include the multiple transport systems, like you can have a road network, and then you combine the rail network the infrastructures to the same networks. Those kind of detail level logistic networks are example of network systems. So whenever we deal with networks in transportation systems, so we require multiple services from the network analysis component of GIS. Best example is the vehicle route, which we are used to use in our daily life. Apart from that, there are a few modifications of those. For example, you may be interested in going from one place to the another places, but in between you would like to have a stops. So if you're planning for a vacations by road, then you would like to have some kind of stoppage in between where you can take rest during lunchtime or maybe in the evening, 6 or 7 o'clock, like to drive and so on. So those kind of additional conditions can be put in a vehicle routing systems, and you get results. Then you can also have a traffic flow. So it means based on the congestion on a traffic, the network attributes gets modified, and you will be able to see the results. The closest facilities are like the facilities which is available from locations, from particular locations. So like if you would like to know the nearest 3 hospitals present locations, so those are the closest facilities. Then you're also having a resource allocation. So that is basically you're having multiple resources, and you would like to know what is the catchment area that location. So that gives the kind of idea on a particular service systems. And it also says that in general, what is the expected and average time to serve a whole area. Then we can all, and these areas is being again defined not on the basis of distances, that aerial distances, but rather than distances completed over a road network. So you can also associate the cost, for example, the minimum time within the reach of 5 minutes, 10 minutes, and so on. So those kind of conditions can also be. And the other network analysis includes the kind of cost matrix. It means you may be having a multiple path from one locations to the another locations, but you would like to know the cheapest cost of transportations to reach from one place to the another places. So most widely being used in aviation industries. So in all these different kind of services, generally we can broadly classify the kind of services or operation which we expected from analysis are that the first one is finding out the optimal path. So it means there will be a few cost you will be providing, and based on those costs, the algorithm should execute behind the screen and then gives you the output, again using the different attributes of your data sets to the path which needs to be followed. So it also requires a kind of user network order. So accordingly, modifies its behavior, and it gives you the kind of segments, multiple segments from one locations to the other locations. Those are basically optimal. Then the other part is that you break down your whole network into different compartments. Is the area which is covered by analysis, and another one is which cannot be covered by an analysis. So in such cases, the algorithm falls the network partitioning algorithms. So the example is the services or the kind of queries where we need to different places which we can visit in let's say in 1 hour from the current locations and so on. So it just divides the whole network. One part says that which can be reached within a 1 hour. Another part show the portion of the network which is reachable in These are the two basic level operations classification. So let's take an example of the optimal path finding kind of problems. So where we have or where we require to find out the travel route. Generally, travel routes includes starting and ending points, and along with the cost associated with that. And in most of the analysis of such, wherever we need to carry out such analysis in our network, so we need to make sure that all the different components of network, that is the road segments and the corresponding nodes, are connected to each other. So there's no portion of the road which is not connected as a whole. So that particular topological relationship between different component network has to be carried out. And we also require a kind of additional cost function. The cost function are functions which takes care of the problems like minimum distance, to find the minimum distance, or the cost associated in the sense that it takes minimum time. Or, can also say that it requires a minimum fuel if you are traveling from one place to another place and so on. So those kind of cost can be built in based on the network length and segment along with the multiple attributes which may be present in your network data sets. And these problems then solves and these when these information is being provided, then under that we get a kind of solution in terms of directions or also able to find the partitioning. So this means next level of partitioning of your data sets before you can also use it. The famous problem is that the traveling salesman problem is nothing but someone needs to travel all the different locations in his wish list with a minimum time or minimum distances which using under which he or she can cover the areas. Such kind of problems are called traveling salesman problem, which is again a kind of problem. So all these analysis requires a set of data sets from the network, and that network is to be converted into network data sets, which is a kind of special format presentation of information, which will be used during the GIS analysis. And finally, that GIS analysis you can store it in different geodatabases. Like ArcGIS provides you that flexibility where the network data sets can be stored in your geodatabases. But in some of the cases like QGIS and all, these kind of network assets gets created on the fly. The transport network assets. Once that temporary storage is being created, then it's for access purpose. So all these network data sets should contain additional informations or represents the kind of related to continuity, that is nothing topologically connected components there that can be used for finding out where those are connected to the special relationship when your network is missions. So those kind of network data sets or metrics can be built in to form of networks, and then we can use it for multiple applications like these networks may represent like for air traffic control or line networks. This can also be useful in power sectors and so on. So we can create all such networks, keeping in mind the information of country topographic space, that is where it is located and how those are connections. So edges and can be represented and can help us to represent such network assets. So in GIS, we can get such network data sets from different places. So one is the OSM, is the OpenStreetMap. That's the best place nowadays to carry out a small scale analysis experimentations. You can directly create it from street maps site, then that can use it for your analysis. Apart from that, there's an air traffic which also provides you data sets, and there are a few proprietary web-based services help of which you can also the network assets. So in general, such network data sets generally represents the abstraction. So your network may look kind of quite different compared to the physical representations compared to the data structure level information. For example, first figure in this case shows the star topologies, which is the thing abstract representation of the concrete. All such networks would have different attributes so that you can use it for finding out relative locations or different kind of analysis, or this can also indicate that it if data set is in one is having a one-way traffic or two-way traffic, or the other special width informations like what is the flow of vehicle or materials in a particular direction, so that we can carry out the accumulations or other kind of differences to identify the and once we represent it, then we can use it for different kind of second level analysis like functions, then the basically the ingress and outgress to each network node, giving an importance of that particular area. Then you can also have a cost metrics associated with the each of the nodes. You can also identify that is networks is having any kind of specific direction of information of the flow, or one of the ways using which two separate networks can be connected together. That also we can represent it, and each of the network characteristics can reveal different kind of patterns, like is your network is fully connected, partially connected, is there any possibility of in case of failure of any maybe the impact on the overall networks. So such kind of change and other dynamics of your can be modeled, those attributes can be modeled from the network dataset. So in general, networks are supposed to have a basic attributes like flow, directions, and so on. But apart from that, secondary level of informations can also be extracted, and that can give a very specific results to a network as a whole than just one segment of. So how does the networks are being represented in the systems? So generally, this will be, you can put it into three different broader categories. One is the conceptual models, just basically representing the relations, relationship based diagram, models, and then we can store it in some kind of data storage or the server or databases, so that the we can carry out all those operations which we need to put in. So to build these conceptual or physical models, there's always a kind of logical data models. It helps us to build such networks. Generally, few of the templates get stored in a basic SQL that can be used for modeling the logical data set. So generally, logical data sets are uses the geometrical or the geometrical based solutions, especially the node and edge based solutions to provide outputs. So this is just an example of conceptual models where you're having multiple segments and sections, have a multiple sections, each node will have specific address, and there may be some additional of your networks like road, turn, maybe and so on that can be put in sequences. So this is just a logical or the conceptual level diagram which represents the overall networks and its relationship. Once that gets implemented into a databases, so then this becomes a of physical models. So in general, physical models are supposed to have segments, the attribute like cities and the row network to represent the physical data. In general, physical data models are the data sets which get stored in a databases or some persistent format. All the storage or analysis is dependent upon how well you are conceptualizing your assets. Generally, network components will have, there are multiple network components like each segments, but you may also have turns, intersections, and so on, so that those kind of information should also be represented. Generally, it gets represented in a kind of graph theories, which is nothing but junction points, length of segments that gets connected to it, gets represented in a form of mathematical model as an order pair of two lists, as vertices and edges, where vertices are nothing but a set of edges. Like in this case, we are having 9 vertices, and each of those segments are again getting connected with each other. So that's basically represents the red color segment is called as the edges. So these edges are nothing but a kind of information about the flow of areas or any kind of information these networks. Let's take a few example which is available in basic QGIS to do some kind of physical processing. So one of them is most of these uses a kind of data structures which is either matrix form like based on the matrix adjacency matrix. In this just example where we are having a 5 nodes, each one will be having a 5 columns. So wherever any node is having connections to another node, for example, the node 1 is connected to node 2, to node 1 section, and node 2 is actually getting connected to it. So that connection part is basically represents the edges. So any kind of edges, if you want that how many edges are coming or going then we can keep it into row wise to get the how many edges are going out, and the column wise if you take the indexes then you get the phase information. So we can represent it in a directed or undirected ways. So that's the first one is a matrix representation, and second is a list based representations. So mathematically it represents a kind of finite sets consist of vertices and edges, and these edges are nothing but again in connections which representing the two different belong to vertex set. Those needs to be a kind of order pair if it is an ordered vertices, otherwise their order can be. And finally we use a set of vertices to create a kind of sequencing. So the complete sequence traversal will lead kind of identification of a particular. That's the way it gets represented. So in general, let's say you're having a two ways of operations, which is directed and undirected graph in graphical forms. As you can see in the directed cases, you're having the direction of the function from the other one that just thinks of that or considers the each needs to be of information in both the directions. Let's use this graph along with the other attribute information associated with the edge to find the shortest path using a simple Dijkstra's algorithm. So how does it works? So it's basically looks for the information of the edges. So these edges, the vertices and corresponding edges, weights should be labeled. So, and then we apply a kind of greedy approach where we make sure that the overall cost of the total travel is always minimum compared to any other. So this problem discussed as algorithms try to say solves it. How does it do? So it to do that it requires a kind of nodes list and starting nodes. Like in this case, it's just example of starting node is A, from where we have to present all the using all the nodes. We will try to find the shortest path to each node in this case. So let's take the shortest path. So it's A is already reached locations. Then we find out which is the next node nearest to it. So out of these two, we are having candidates, which is B and C. But fortunately, the C is having the least values compared to edge AB. So accordingly, the C will get selected in list in the new cost associated with that. So once you have found out the cost of A and C, then again you try to find out cost of all the remaining nodes which are yet to. So like in this case, A and C is the one segment of the network and B, D, E is another segment of the network. So we'd like to find out like from each of these output node, how many of them are basically going to be connected to other unconnected node with least amount of resistance. So in this case, A and C are the already been reached. Now we look for the remaining B, D, E, and which one of them are closest to it. So we see that from A and C, the closest node is three different nodes. That is C, D, E is available. Apart from A to B is also available. So different uh, total four different paths are available. Out of which is the least cost to or the node which is nearest to the already reached nodes. So we select that one. So in this case, E gets selected and corresponding gain cost is being put in. Then again, from out of ACE, we look for the nearest node. So we see that D is the cost to reaching D is the least this case. And then finally, from B to is again being left it, and accordingly, we just find the next least cost path. So that's the basically finding out the from one points to find out all the different locations, each of the nodes locations and their cost associated with that. Sometimes there's also an important concept which is called a minimum spanning tree. So which just also can be used to represent the vulnerability in your networks. So it's basically works on a principal Prim's algorithm. So it takes one node, looks for another nearest to node to it, and then it carries out the operations, and finally you get an presenting the traversal of operations. So these kind of processing, which we can do it in just like QGIS. So QGIS is having an this version of the QGIS having an analysis this processing toolbox, and you can use it for finding out the surface area. So like to the notion of another available. So considering the road, so the network then to find out places. Then we can also look for an service area places where from one places which we can shift from that, so on. Those kind of informations can be provided. And then we can also get a shortest path based on the point, or a shortest point from one all the other points available, or maybe the all the other points to a particular point. So these kind of shortest path operations which we can. So for that, let's in this example we'll be using a GIS routing analysis. So generally you'll be having different assets available to you in a, which can be arrived from multiple databases, maybe state level or national level traffic details, and that can be used for doing different kind of analysis. So this is just an example where you're having a supply network starting from suppliers, which is basically is connected to different locations. Or in this case, the yellow dot is the place which you need to reach from multiple places. So in general, the to carry out such a logistic managements, we look for a kind of service area coverage like isochrones, or that basically the cases where we'd like to find out within a given time what are the different places which can be visited in a so those kind of things are called also isochrones service area. So it can also help us to find out service gaps expected even in the physically we may see that the service is available, but inside the network there are few portions which are still out of reach. So such kind of things can be carried out. Then we can find out the shortest path from one locations to another locations. So basically you have to provide a start point or end points and the corresponding network data sets. And once you provide these information, then the algorithms which we have seen earlier, discussed as kind of algorithms can help us to give the complete solutions. As a result, and at the end, we can find out the result of the shortest path segments reaching from one place to another places. Then in case of service area analysis, so from the start point, we would like to be all the facilities from one to distance from particular point to all the location of a particular facility. So these facilities can be the hospitals or maybe schools, which can be reached from one to another point. And based on that, the analysis is being carried it out, and then you can find out, or you can provide the information that which of these segments are what distances. So this is the shortest path between which you can find out using the QGIS tools called basically shortest path to point to layer. In some time, we also do a kind of real-time rerouting. So you may be having a path available lines, but as the situation changes or you move or some kind of traffic is there, so those kind of rerouting is possible and which can be carried out in using the application like PG route and so on, and solutions in a QGIS environment. Then there's also a possibility to find out service area. So in this case, what happens is that you start or you take one point and then you look for from that point what are the different segments of the road can be reached. So like in this case, we can provide the distances of 1 kilometer which can be reached from one particular point. So in this case, it gives you all the highlighted segments which are within the reach of kilometers. So similarly, you can also have based on time and so on. We can find out using the service area solutions. Then there are from layer to layer, so it means like you can find out what are the what are the part of the networks which can be covered within a particular range. Those range can be a distance metrics, like in this case, all the places, the road segments which can be reached from the 5 kilometers. So such kind of analysis gives the service gaps, opportunities, and as well as the catchment available on a true network, true network datasets. So with this, we are going to end the current session. So if you have any questions, please post it, and we'll be happy to